Hello everyone, you are welcome back to Shabest online tutorial. In today's tutorial, we are going to learn how to evaluate the limit of this indeterminate function using L'Hopital rule. And the function is what? X to power 2 e raised to the power of negative x to power 2. And at the limit, x is approaches positive infinity. The first thing we are going to do is to first simplify this function. So this function is the same as our limit as x approaches positive infinity x to power 2 then divided by e raised to the power of x to power 2. So this is x to power 2 and this is going to come down because of this negative exponent. Recall when we have x to power negative 2 is the same as 1 all over x to power positive 2. When this is going to come down, the negative is going to turn to positive. This is what we did here. E to power negative x to power 2 is going to be e to the power of positive x to power 2. So when we do direct substitution, when we plug in infinity here, infinity raised to the power of 2 is the same as infinity, then divided by, when we plug in infinity here, e raised to the power of infinity is the same as infinity. Then infinity divided by infinity is undefined. So that is the reason why we call this function indeterminate function as x approaches infinity. So what we are going to do using L'Hopital rule, the rule say we should differentiate this function separately. Then before we do direct substitution, we're going to differentiate separate. So this is going to be our limit as x approaches positive infinity. The derivative of x squared with respect to s is the same as what? 2x divided by the derivative of exponential x squared. Derivative of any exponential function is the same as the function itself multiplied by the derivative of the exponent. This is just a simple trick to differentiate exponential function. So the function itself is s exponential x squared, and the derivative of the index, the derivative of x squared is the same as 2x. So this is going to be 2x multiplied by the function itself, x to power e to power x squared. Now we're going to do direct substitution and see whether we are still going to arrive at undefined. When we plug in positive infinity here, 2 multiplied by infinity is infinity. Then when we plug in infinity here, everything here is going to be infinity. Infinity divided by infinity is still undefined. Then we redifferentiate again. This is going to be our limit as x approaches positive infinity. Derivative of 2x with respect to x is going to be 2, then divided by derivative of 2x exponential x squared is going to be what? The derivative of the index is s to power 2. The derivative of s to power 2 is 2x, and that 2x multiplied by 2x is going to give us 4x squared. Then the function itself is exponential x raised to the power of x to power 2. So now we're going to substitute at x approaches infinity. So the up one is constant. We're going to keep it as 2, then divided by, when we substitute infinity here and put infinity here, so everything is going to be what? Infinity. And 2 divided by infinity imply 2 is dividing a very large number. So this is going to be what? 0. So therefore, the limit of this function as x approaches positive infinity goes to 0. Thank you for watching, and please follow and subscribe for more videos like this. Thanks.